Right, welcome everyone. This is your Find Your Fit in Engineering at UTS webinar. So it's 6 p.m. now, so we're going to start the webinar. So welcome everyone. This is basically a really good webinar for those of you who might be just finishing up with school, so currently in your HSC years, gap year students, parents, guardians, even guidance, teachers, education officers, anyone who essentially wants to have a better idea as to what UTS is offering in terms of engineering courses, but also in terms of our majors, which is often a very confusing time for students to decide on what exactly they want to do. So today we will be talking through quite a lot. There's a lot of information, but luckily we will be recording this entire video and we'll be sending it to you afterwards so you can sort of go through it, write down notes if you need to, and sort of refresh your brain whenever you need to. On top of that, we'll also be covering things like entry pathways, scholarships, real student journeys, and also about how UTS can set you up for success in industry, so after university, of course. Now, as I mentioned, this session is being recorded. Just note that we're only recording the audio as well as the screen share. So that's the PowerPoint presentation that I'm just sharing right now. Obviously, we will not be recording any video or audio input from you as the audience. If you have any questions about this at all, just please email this email address that's down at the bottom, highlighted in blue. Otherwise, the recording will be sent to you afterwards so you can watch it in your own time. Now, before we get started with our presentation, I just wanted to acknowledge the Gadigal people of the Eora Nation upon whose ancestral lands our city campus now stands. I would also like to pay respect to the elders, both past and present, acknowledging them as the traditional custodians for this land. Right, so we're actually quite lucky today. So we've got 3 speakers in total, but we've got four individuals from UTS who will be hanging around helping to answer questions for everyone. So firstly, we have Chris Wong, who's the Director of Education in the Faculty of Engineering and IT. So Chris Wong will essentially be running us through all of the majors that are available at UTS and basically give you an entire big picture of how engineering looks like at UTS. We'll also have Karen, who will be helping answering questions towards the end of the presentation. So definitely hang around if you've got any burning questions about our courses. On top of that, we also have Olivia, our current student, so third year student. So Olivia will be sharing a little bit about how her day-to-day life looks like as an engineering student, but also how she got interested in her mechatronics engineering course. And lastly, but not least, we've got Erin Andrew, who actually graduated from UTS in 2024 with a Bachelor of Engineering Honours and is now currently employed as a quarry supervisor at Boral. So quite a lot of different people with a lot of different experiences, but all very eager to chat with you guys and share their knowledge. So without too much delay, I would like to first run through what we'll be talking about today and then passing it straight on to Chris. So today, essentially, what we're hoping that you guys will come away with is a little bit of extra knowledge about how our engineering majors are designed at UTS, but also how they work across boundaries. And what I mean by this is how our majors are incredibly flexible, how they can be multidisciplinary, and how you can make an engineering major work for you, and how you can pick something like mechatronics, which you might not have considered before, but end up in a job that might not be mechatronics based. And that's the beauty of engineering. So that's something what we want to very briefly delve into. On top of that, we will be hearing from current students, from alumni, and of course, all the nitty-gritty information about admissions, entry schemes, and all of that fun stuff. So I'll now pass it on to Chris Wong to guide us through quite a lot of information. Don't worry, you're not getting quizzed on all of this. Chris will guide you through, and I hope you guys learn quite a lot out of it. Thanks.
Thanks very much, Pat. Look, thank you very much for introducing me. I'm going to talk a lot about engineering today and a bit about on the side about other things as well. But just be aware that we've got the Bachelor of Engineering Honours degree. And the reason why it's honours is because it's a 4-year degree. And also what we do is we train you for advanced discipline skills, not just ordinary bachelor's degrees. So I'm going to focus on mainly our main discipline areas at UTS, which is biomedical engineering, our civil environmental engineering, our electrical, electronic and data engineering, our mechanical and mechatronic engineering, chemical process and flexible engineering programs. And then I have a slide on our diploma, our internship program called Diploma of Industry Practice. Pat, next page, please. Thanks. All our degrees are structured the same way. We have 1 year of a core. So you have a common core shared with every major, whether it's all the way from civil to software engineering, it's the same core. We then have 2.5 years of a major, and I'll talk about the major shortly. We have 2 3 credit point. It's a 12-week program for what we call an industry practice program. We do work experience as well as preparing for it and reflecting on it afterwards. But I will talk a lot later on an option that you have as domestic students to have a whole year's internship, which replaces our industry practice stream. And finally, we have electives. So that's half a year of doing virtually anything you like. There's one caveat with that, though. We have a special offering called double majors, which are 3 years. So we're the majors plus the specialist streams what you have to do instead. All right. So Pat, if you don't mind, go to the next page. I'll talk about the engineering majors in general. So we've already have 2 main streams of engineering at this university. We have the standard Bachelor of Engineering Honours, which is very similar to all the other universities, a 4-year degree with a 12-week internship or work experience, what's really called. But we have a special offer called the Bachelor of Engineering Honours Diploma in Industry Practice, where you have a chance to do 2 6-month internships. And we'll talk about that in about 4 or 5 slides. So let's go to the next slide, Pat. Thank you. So the very first major we've got, which is extremely popular, especially with female students, is the biomedical engineering. Now, this is very different from the traditional engineering because it links in with the engineering skills, which is about design, problem solving, and mixing it with medicine, medical science skills, and biology. The idea is to improve healthcare using engineering techniques. So that allows us to develop things like medical technologies, for example, biomedical sensors like those ECG machines, those things go beep in hospitals, or artificial limbs, prosthetics, or even artificial organs like an artificial heart, for example. And a good example is I'm wearing a hearing aid at the moment. That's a classic example of a biomedical engineering, which links in sensors, AI, machine learning, as well as things like Wi-Fi and Bluetooth, would you believe it? So it's a very interesting major to do because you can actually focus on different areas. We have subdivisions of biomedical that you can do at UTS, and that includes things like bioinstrumentation, where you can actually look at the sort of things that go beep, I guess. Imaging, like X-rays, MRIs, CAT scans. Genomics, where you understand the raw data, you collect the information and make sense of it for medical innovations. A good example is people have been making things like those tests, rat tests used for COVID, for example. That's what biomedical engineers do. So they're very interesting career choices in that particular major. Pat, next slide, please. So on the other side of the scale, a lot of people, when they think of engineering, they think of buildings. So we build infrastructure. We build houses, towers, bridges, as well as other things that you mightn't think about the civil engineering. For example, what we call environmental engineering is a form of civil engineering that's involving things like pollution control, water supply, sustainability. So the general techniques you learn are the same. We learn about design techniques, we apply mathematics to these design techniques, and we learn how to be safe, environmentally responsible. We learn how to get information, for example, traffic information to make roads that are safe. And we've now got a big issue with developing housing, for example. So civil engineering is such a huge field. And because of that, we have multiple streams of civil engineering. The classic civil engineering is a generalist role. You do all these things, but you can focus on structures, and that's where you do more mathematics. You focus on using computers to design these gigantic buildings or design bridges. And it's basically using huge, gigantic formulas and behind a CAD system. Or you can focus on construction. For example, we've got the West Connects, we've got the Western Harbour Tunnel, all those different techniques on how to apply our engineering skills to making construction flow smoothly. And we actually tend to work with the building construction people in the Faculty of Design and Society, the architectural faculty, or you can be focused on environmental skills, which is also extremely important today's, dare I say, climate environment. So let's talk about a slightly different one. Next slide, please. Okay, so next thing that we do teach at UTS is the electrical and data engineering streams. Now, this is really 3 streams that you have a choice on. The first one is electrical engineering, where we focus on circuits. So that's things like electricity, high voltage, low voltage. We design things like how the power flows from the generation. That includes renewable energy or traditional, dare I say, coal or oil or gas generators, all the way to how we connect that to the grid, which is like Osgrid, connecting from the generators to the actual users of electricity. And we also learn about how to connect all these things together. So this is highly focused on power, control, and embedded systems. Now, a slight twist of it, a slight variation of electrical engineering, is what we call electronic engineering. Now, this is where you're involved in working on the digital systems, digital circuits behind the controls of all the things that you do with electricity. For example, you might have something that controls Internet of Things. For example, sensors in a house that turns lights on and off. Or you might design a circuit that does things like an integrated circuit that might be connected to a computer, for example. So you're delving into the internals of the integrated circuits inside an electrical system. And that involves a lot more mathematics than the standard electrical. So a bit of quantum knowledge is also required in that particular technology. And they also do communication technologies like those routers and switches, how to actually code the insides of those things. So it's a big variety all the way from large-scale systems to the micro-tiniest systems. We might have these tiny microsystems that collect information, and that's where we lead into data engineering. Now, data engineering is a bit unusual. It's the interface between that electronics, collecting information like sensors, making sense of it, and then analyzing it using traditional data analytics and data science techniques. So statistics, machine learning algorithms, even a bit of AI. And typically a good example of that is systems that, for example, manage buildings. So we're in a building, the lights turn off because nobody's inside. That's a data science type job. And they also do things, for example, analyze how the power is used in the building. Say, well, maybe we won't run the lifts at this time of day. Or you might collect information like the Opal card. We're able to transport New South Wales. We tap on, tap off from trains. We collect that information, store it somewhere, and make sense of it. So suddenly State Rail might, for example, realize that nobody catches a train at 11:55 p.m. from Strathfield to Central. That's the information that a data science engineer does. The combination of a bit of that electronic engineering understanding, combine it with that computer science, data AI engineering. So it's an interesting combination which is future focused. Next slide, please. Thank you. Now, I did mention data engineering being that intersection between electronics and software. Now, you might ask the question, isn't software just programming? Actually, it's a bit more than that, because coding is something which we also teach in IT, in cybersecurity, Bachelor of AI. Software engineering is slightly different. It's focused on applying the engineering skills to software development. And it's a big focus for us on doing things like how to repetitively do software, how to make it safe and reliable. So you may have had a crash, for example, on Microsoft Windows, a blue screen of death, they often call it. Well, if you're flying in a plane or a car, if the system crashes, it could actually be a real disastrous thing to happen. So software engineering is highly focused, not just on coding, but making extremely reliable, efficient, and repeatable and manageable. So big focus on the process of doing software, not just the coding itself. So typically you'll find software engineers will manage teams of IT developers, programmer analysts, fellow junior software engineers, and maybe some of these cybersecurity experts and business analysts as well. So software engineers tend to be the big integrators. They're in charge of the full system and how it's developed. So you need to have a lot of management skills in this particular major as well. And we'll teach you a lot about that, what we call studio, where you actually get to emulate real world companies and real world processes. Um, Next, please. Okay, now this is a really fun one because when engineers first came out a long time ago in the 1600s, engineers were do-it-alls. They did everything from designing vehicles, well, carts and horses, I guess, to water type, to civil engineering. They were actually the original engineers. So they were focused on applying mathematical techniques to design analysis and how to make things and then how to maintain things. So if we scale up mechanical engineering nowadays, it's everything from moving things like cars, manufacturing, but also things like things that move inside buildings. You may not be aware that the air conditioning systems, heating, ventilation, air conditioning, is actually run by mechanical engineers. So there's a lot of work for mechanical engineers in the civil engineering space. When we build buildings, these are the people who manage the things that move air, move liquids, move fluids as well. So it's a very interesting field to be in. A slight extension and some recent innovation in the last 30 years is mechatronic engineering. And that is actually mechanical engineers with adding in electronics, like I mentioned earlier, the electronics, the embedded systems with computing plus AI. And often people put things like mechatronic engineering, are they robots? Yes, but it's more than robots. It covers things like automation. For example, the lifts in our buildings. That's actually designed by mechatronic engineers because you have a moving component, mechanical engineering component, plus a bit of electronics. We get the sensors, we run the motors, and then we've got the buttons. We control the lift going up and down, whatever. That's a mechatronic engineering type job. So all the way from robots to automated systems. So there is a lot of coding in mechatronics. Just be aware of that. And because we need to do that, they need to understand how things move. That's called dynamics. They need to understand things like heat. For example, if a motor gets too hot, or how these liquids move around in their air conditioning systems, and also how the materials as well. We need to understand what steel is, what plastics and all the different materials you use in the various constructions. One of the recent things we add a lot in our particular course is additive manufacturing. You know, that 3D printing, that we do 3D printing at a massive scale, all the way to metal 3D printing, which is pretty amazing. So this is the future focused applications. We're applying all these skills to what you can use for the future. Okay, and don't forget, you can also, if you really like it, combine both together. Be a mechanical and mechatronic, and that's a very popular combination of majors that we've got at UTS. So you have both sets of skills, and you're qualified in both fields. Next slide, please, Pat. Okay, now I did mention flow of liquids that mechanical engineers understand. An extension of this is what we call chemical process engineering. Now, notice we use the word process here. And this is actually a very key job to have in the modern world we have. We're focused on changing what we call raw materials, like oil, or biomaterials, like, for example, I like to use the example beer. We have hops and biological fluids that might be converted by a process using heat or perhaps pressure as well, and convert them into things like food, medicine, even clean energy. We get heat from these things, use it to build the extra things like the manufacturing process. And to be safe, we have big focus on safety and how to be sustainable when we do this. So notice it's chemical process engineering. So we're very heavily focused at this university on the process of doing this. So we do some chemistry, chemistry 1, chemistry 2, and some of that biological cell understanding and thermofluids, but we tend to be focused on the IT side, or I would say computing side. So we have massive simulations of factories. We run things like those giant, showing how fluids move from point A to point B in a factory type setting, a virtual factory. And you are actually a professional who can actually manage these processes. This is actually very important when you're dealing with creating food and creating things like, I wouldn't say the mining industry, but more like the oil type, refinery type industries. So our chemical processes focus very heavily on processes instead. Um, Next slide, please. Okay, now there's a huge choice of stuff we've talked about just then. It's probably, you may be really confused saying, look, I'm not really sure I want to do civil or mechanical, or maybe a bit of structural or construction in that, or maybe a bit of process engineering as well. We allow you to have the option to do what we call a flexible engineering degree. Now, the big difference between this, you might have heard the word flexible first year at other universities. Yes, this is a flexible first year. You can you can do multiple introduction subjects in the first year and then make your decision in the second year. But we also have a special option that if you can actually choose to focus on a I wouldn't quite call it build your own degree because we have constraints from Engineers Australia, but you can say, I want to be mostly a mechatronic engineer with a lot of software. So you can choose options like that for the structure of this degree. There is an option to be very, very focused on a particular field. You can do that as well. And we have things called sub-majors that allow you to focus these fields. For example, if you like civil engineering, but you like the transport side of things, we have a major called transport that you can focus, sub-major, you can focus on that instead. Or you could say, I'm actually very interested in mechatronics, but I want to do more software on top of that as well. You can do some of the software engineering subjects as well as doing the core components of a mechatronic degree. So you do have the options there. And I happen to be the supervisor for that particular set of engineering options. So if you choose this option, I'll tend to talk to you on a one-on-one basis and we work out your plan and work out whether you want to go into your actual major in the second year or continue on in a focus area of your interest instead. So I hope you have some interesting questions to ask on that one. Pat, can you go to the next slide, please? So we talked about the structure of our degree, that it tends to be 1 year of core. That's common to everybody. And we have that 2.5 to 3 years of a major or double major and some options. And one of the options, one of the core items we have was called industry practice program or professional practice program, it's called. All engineers have to do a 12-week mini internship. We call it a professional practice program. But you've got the option at UTS to do a whole year. And we call it Diploma of Industry Practice. And this is where you do 2 6-month internships. Now, the important thing is, and we really highly encourage you to do this, so it's an option when you go to university admissions. In second year, we'll put you in a 6-month internship called a junior internship, where you will go out, work for 6 months with an employer, and you're a junior at this point. So you don't really expect to do, for example, mission critical work. You'll be like the shadow to the project manager or to the senior engineer, for example. And you'll learn how the companies work. You'll learn the things that they do. You'll look at things like, for example, oh, here's a giant CAD diagram. You're going to be working on that. Or here's a project management charts, and we'll be working out in the field, walking out under a tunnel and see how things work. So you would learn skills that are critical for both your own professional development, but also tying in what you learn in the introduction subjects to the real world. And that's really useful because it helps build your confidence that you know what you're going into on your subject you do after your first internship. And we always find that the students who do the first internship come back more confident and actually have better results. We actually have statistical analysis on this, better results and better outcomes for the rest of their engineering degree. So I highly encourage you to think of that. Now, we have over 1,000 industry companies that do offer internships. We have a system called Career Hub where we publicize these internships. We give you what we call preparation subjects. We teach you how to act professionally in the field, how to write your resume, how to sit the interviews. And it's such a useful thing. It's a lifelong skill that we teach you at this point. And you'll find what's an interesting point is a lot of our students on that very first internship employers will like you so much, they'll say, can you work for us part-time? And that happens often. They'll say, look, can you please stay with us? Will you still study your part-time or full-time? You'll do some work for us, maybe a day or two a week, because you're such a valuable member to our team. So it's a very useful thing to do. Then you go back to your classes in the third and fourth year. And at the beginning of your fourth year, we have the second internship. We call this a senior internship, where often be asked to do some more, I call it meaty work, where, for example, instead of just being a shadow, you might be asked to do things like, for example, quality assurance. You're on where they're laying concrete and they're laying the senior engineer is checking the installation of the reinforcement. You'll get a chance to have poke around and actually get hands-on work. They tend to trust you more at this point because you've at least had 6 months of experience. And again, more students get jobs through that than any other mechanism. So that's why we have extremely high employment rates for students who do the Bachelor of Engineering, Diploma of Industry Practice. Highly recommend to do that. And I'd also point out to you that most of these internships are paid. You're obviously not paid as a full engineer, but you're paid at least at the junior rates. And one thing to note as well, that this program has been accredited by Engineers Australia to help you get what we call stage 2 competency. They treat it like you've had 1 year of work experience in the industry already. So when you leave your degree, you already have 1 year's advantage over peers from other universities as well. Okay, so I hope you're excited about trying that. I highly encourage you to go for it. Pat, can we go to the next slide, please? Okay, so I did mention quite a few times that, for example, software engineering students often end up as the team leaders of multidisciplinary teams, IT students, business analysts, and so on. So most engineering challenges aren't just a single field in a discipline. Building a building, civil engineering, for example, engineers have to work with many types of people, architects, construction, builders, workers, electricians, as well as your customers, managers, finance people. So engineering at this university, and most universities as well, really, you learn how to work with other disciplines as well. So as part of that, we have a subject in your electives called the TD elective, where you get to work on projects with everybody from all over the university. They could be art students, they could be nurses, they could be architects, they could be business people, they could be scientists, as well as fellow students from different disciplines as well. So it's a core skill that we want all students at UTS to have. So in our engineering core, we teach you these skills continually. So we have not just one subject in project management, we have a whole stream building up your skills from what we call introduced or foundational skills developed to what we call pre-professional skills in your final years. So we build you up. So first year, yeah, it might be fairly easy, to the fourth year where it could be challenging. And you'll be scaffolded with those skills for every semester you're with us. Okay. So just be aware that we have many, many options for you. And a lot of our projects, we have studios, we have actual industry people come in. And for example, in the electrical studios, some of them actually offer projects where you work on. Now, obviously, they can act as mentors or as your customer. So you get a glimpse at this point, at the early stages of real world projects. But by the time you get to your capstone in your final year, a significant portion of your major work for your degree are actually working with customer type projects or research projects as well. So it's quite exciting. In fact, the UTS Capstone Showcase is worth coming to because you'll see what our students have actually done their final year, and they're amazing projects. So Pat, can we get the next slide, please? Okay, so I mentioned that we work with many types of disciplines outside. You can choose, and a significant portion of our students choose, to combine your Bachelor of Engineering with other degrees. For example, Bachelor of Business. So you do a very common combination is Bachelor of Engineering with a Bachelor of Business majoring, for example, in management or finance or accounting. So very common combinations like that. Or a Bachelor of Science focusing in mathematics or physics, which tend to be what a lot of engineers tend to be focused in. You can do a Bachelor in Medical Science, especially if you're doing things like biomedical engineering, a lot of overlap there. So you get a chance to enrich your degree significantly. Um, the Bachelor of Creative Intelligence. So I did mention that one subject called TD, where you work with other students. This is an expanded version of it, and it only adds 1 year to your degree. And the final year actually includes things like a startup internship, for example, or innovation projects. And a new degree we've had for 2 years now is a really exciting one. It's called the Bachelor of Sustainability Environment. So you do your degree, and then you can link it with another degree, which you cover things like about sustainability in our modern world, climate change, mental sustainability, and you're working with students from all different disciplines as well. A really exciting degree. In fact, you can even use that degree to add extra subjects that may be outside your discipline. So you're electrical, but you might do a bit of environmental planning and law, something like that as well. And finally, I did mention the Diploma of Industry Practice. If you do a double degree, you can still do that Diploma of Industry Practice. It doesn't show up on UAC, but it's an add-on, so you can add it on. So you can still do Bachelor of Engineering, Bachelor of Business, as well as that diploma as well. So keep that in mind. Next slide, please. Cool. All right, so this is near the end of my talk, so I hope it really set up everything for really exciting opportunities out there to go into engineering. I just want to make sure that you're aware that most of our scholarships are now closed. You had to apply early. We still have one really valuable scholarship open at the moment, the Dean Scholarship. It's worth 30,000 over 2 years, and it close on the 8th of December. So I'm going to leave that QR code up so you can quickly take a photo and scan it. Apply for that. Best thing is to try to get in. Now, this is for high achieving students. So if you think you're going to get a good mark, and don't forget, you include your adjustment factors as well into this. You'll apply for it. If you don't apply, you'll never know. So apply for this Dean Scholarship, and it is such a useful thing to do. Okay, so I'll leave that for a moment so you can scan up your QR code. But after this, I'd like you to hear from one of our existing students, Olivia, who is from, I think she'll introduce herself, but it's extremely valuable to hear what our current students feel and what they're doing. So I'll hand over to Olivia now, if you don't mind. Hi, Olivia.
No, awesome. Thank you so much, Chris. And yes, I do 100% recommend applying for internships, as Chris was saying.
And
You
a
miss
scholarship
100%. Sorry, scholarships. You
as
miss
well.
100% of the shots you don't take. And I do know some people who have gotten it simply because no one really applies for them. So I'm Olivia. I'm in my third year of engineering and I'm starting a major in mechatronic engineering. So like a lot of you, I was pretty unsure on what I wanted to do in university. I actually didn't know if I wanted to study engineering in the first place. So I was accepted into UTS through both UAC and early entry offers. So if you're in year 11 and you haven't got into the actual application stages yet, I would definitely be looking into both of those. And I chose engineering probably because of its practicality and the ability to get hands-on experience, especially here at UTS. So thanks, Pat. Next slide. So my study journey actually looked like choosing flexible engineering in my first year. So like Chris was mentioning, flexible engineering kind of allows you to pick and choose what you want to do at UTS. So I actually went into engineering and took an intro subject to civil, and I took it for like 3 weeks, decided it was absolutely not the thing for me. I actually swapped and dropped out of that subject like 3 days before census day and was able to swap into something else. I chose an intro to mechanical engineering subject, and it was honestly the best decision for me. So you can kind of see on my study journey, there's a lot of hands-on experience at UTS across all engineering disciplines. You do get to make a lot of projects, and this is really good because of the hands-on experience UTS gives you. You're able to show employers that you are getting that industry kind of experience. So in my first year, I was able to make a catapult and also a pinball machine in that was in Intro to Mechanical Engineering and Intro to Mechatronics Engineering. And then through my past 2 years, I was also able to make a fully functional robot from ground up using my own microcontroller and then all the different subsystems, and then also designing and developing my own PCB from scratch in a team. So I think the biggest things I've loved about studying here at UTS is everyone's really welcoming, and most of the subjects are structured, pretty consistently. So as Chris was saying, university gives you a lot of support in finding internships, but it's also up to you guys to decide how you want to go about this. So there is a fail-safe option if you guys were ever worried about finding an internship once you get to university and once you're in that second and fourth year, especially if you're taking the diploma. But as a lot of your high school teachers are telling you, I assume it really is up to your own initiative. Like me here as an ambassador is because I've gone out of my way, I've spoken to some people, and I was able to get a job here at the university, which has also put me on the right path and has allowed me to talk to my future employers about kind of the talking skills and interpersonal skills I have just beyond engineering, which puts you on a different kind of playing field to your peers. So next slide. So, studying engineering at UTS isn't just all about your studies and academics, too. I would highly, highly, highly recommend that you employ yourself with the student experience. So, my time at UTS has been involved with a lot of societies. So, this year I had the opportunity to be the president of our Student Society Engineers Without Borders. We got to go on a week-long trip to regional towns in New South Wales and essentially teach kids about engineering, which is really rewarding. And not only being able to have this experience, I've made a lot of my closest friends at university, even though they're not in the same major as me. So I'm still close friends to them to this day. We have calls, we catch up with each other on campus, and yeah. And so the other society I'm part of is MexSoc. So it's really important to kind of have a good range of places you're on campus and people that you meet because it's not just about people that are in within your own major. It's also being able to network and talk to other people within UTS and just in the engineering field in general, because that student experience is really what makes the difference between your degree kind of just being academic and a little bit boring to actually elevating it and being able to learn through your peers and make a degree interesting to you. Yeah, thank you. Just passing it on to our alumni. So once you guys are out of uni, our alumni Erin is going to speak about her experience.
Thanks, Olivia. It was great to hear about what's going on at UTS at the moment. My name's Erin. Thanks for the opportunity for me being able to tell you my story, how I got to where I am today. And I hope I inspire some of you to imagine what your future might look like. So I studied a Bachelor of Engineering honours in civil engineering. And as Chris mentioned before, I had that diploma in professional engineering practice. It's called something slightly different now, but basically the same thing. I had 1 year of work experience throughout my degree, which was really valuable to me. Okay, next slide, please. So in high school, I was a little bit lost. I didn't really have a favorite subject and I was unsure of what I wanted to do after high school. I had an interest in technical drawing. I loved drawing floor plans, as you can see in one of those images there. I also loved doing project work at school. So whenever I got to do a group project or even an individual project, I just loved seeing a project out from the beginning to the end. While I was at high school, since I wasn't sure about what I wanted to do, I reached out to a building facade design firm, which was an engineering firm, just to kind of see what engineering was all about, because I kind of had no idea what engineering was. And I was really glad that I did that because I realized that there's so many opportunities that can be open to you through an engineering degree. I remember hearing throughout my degree these statistics that in the top 500 CEOs of the world, about 30% of them have engineering degrees. So there's lots of opportunities if you study engineering, even if you're not sure of where you want to go right now. I also applied for the Women in Engineering and IT scholarship. I thought I had no chance with the scholarship. I thought that I didn't do very well in the interview. I was very nervous in the interview, but I was very pleasantly surprised when I got the phone call that I actually received a scholarship, and that I was really grateful for that opportunity. Next slide, please, Pat. So when I started out at UTS, I had 8 subjects in my first year, and as you can see, there's a wide range of subjects there, a mixture of technical skills and soft skills. So it really helps you to find your way in your career in the first year, and the option is there for the flexible first year if you're not sure. So the balance of subjects was quite good for me in the first year, and especially the intro to civil subject, which Olivia said she didn't really like, but I enjoyed that subject. So everyone's different, I guess. I kind of got to hone those technical drawing skills that I really loved working on. Next slide, please, Pat. So as a part of my scholarship, I was provided with opportunities for two different companies. So they were the sponsors for my scholarship. My first internship was at Ward Civil and Environmental Engineering. And throughout that internship, I got to see out the completion of a roadworks project. So that experience helped me to kind of understand what was involved in the industry, build a few industry connections, and also practical skills. So I got to do a bit of quality assurance towards the end of the internship. I got some technical skills in surveying and also the project management side of things. And the diploma also provides you with an opportunity to kind of reflect on your internship and figure out what worked, what didn't work, and what you might do in your next internship to improve. So that was really good. Next slide, please. My second internship was with Boral, which is the company that I work at now, at Pepper Tree Quarry. So Pepper Tree Quarry is quite a big site. It supplies all of the aggregates for Boral's asphalt and concrete products in Sydney, or a large portion of their concrete and asphalt products. So through this internship, I again built lots of connections in the industry. I got involved in the IQA, which is the Institute of Quarrying Australia. So a lot of networking opportunities there. And I also built a completely different type of technical knowledge to the roadworks project. And I think it was really valuable doing two completely different internships because it helped me kind of figure out where I wanted to go. And I was lucky enough that after my internship, Boral wanted to keep me on part-time. So I did some part-time work between my internship at Boral and the completion of my degree. And now I'm completing my full-time role at Boral as a quarry supervisor. So I supervise a team of about 30 people, and I'm involved in the engineering of the quarry pit and ensuring quality products go out to our concrete and asphalt plants in Sydney. Next slide, please. So I was also lucky enough to do an industry capstone project. So Boral actually supported me with my capstone, which is the honours part of the degree. So that's my final year thesis. My thesis was on creating a grout product with a waste product from the quarry that I was working at. So there was a bit of an environmental focus with that as well. And it was a really good opportunity to see the research side of the company and also UTS. A really good experience there. I found out in November or December 2024 that I was going to be working full-time at Boral. So I was very happy about that. And my graduation ceremony was this year. I still say it was probably one of the best days of my life. And I graduated with first class honours. That was a really good opportunity to catch up with my peers and see all the different pathways that people went down. And a lot of my peers are very successful in their careers now, and I was very happy to see that. So thanks, everyone. I hope you found my presentation valuable. Passing it back to Pat.
Thank you very much, Erin and Olivia, and of course, Chris, so all of our speakers. I'll just remind everyone that the Q&A is open, so you can definitely start popping in any questions. So you just have to scroll down to the bottom of your page, and there's like a little question mark icon, which you can click on, and you can type out your questions, and we will address them towards the end of the presentation. In the meantime, I will continue to just talk through some of the additional information that you might find handy in the upcoming few months, particularly those of you who are leaving school very soon. Sorry. So basically, UTS welcomes students from all HSC subject backgrounds. So what I mean by this is that an entry into an engineering degree, there really is no assumed knowledge of HSC mathematics. We do recommend certain mathematics, so Mathematics Extension 1, Advanced English and Physics, but in saying that realistically no prior experience is needed. You also don't need to have taken any engineering studies subjects at school. So for those of you who did go to school and found that your high school didn't offer any engineering subjects at all, that's completely fine. Generally speaking, in your first year of engineering, you tend to go through a lot of foundational subjects, so you'll be able to catch up with everyone else and essentially study at the same rate as everyone else. In saying all of this, for those of you who feel like you might need a refresher in your mathematics skills, or perhaps you didn't take Mathematics Extension 1 or mathematics and you feel like maybe you want to take it now, UTS, like a lot of other universities, offers bridging courses, which are essentially mini courses that will cover these subjects. And this happens during the summer period. So generally it happens around January to February. So essentially you'll just sign up to one of these classes and then you'll just attend them, and it essentially refreshes all of your high school knowledge. Again, it's not something that is necessary, but something that some students definitely do. Now, ATAR and adjustment points, or sometimes referred to as bonus points, I believe they used to be referred to as bonus points. So just so everyone's aware, these adjustment points are added to your raw ATAR, and that then forms your selection rank. Points can be given for several reasons. So I've included a couple of reasons just down below. So one of them would be special circumstances. So there's an educational access scheme, and that will actually give you 10 whole points, which is really, really good. Obviously good results in relevant HSC subjects. So obviously your physics subjects, your mathematics, and so on, and any engineering studies, those will also give you up to 5 points, which is fabulous. We also have something called the UTS Engineering and IT Questionnaire, which I will cover in the next slide, but essentially that will get you up to 3 points. And also Women in Engineering and IT will automatically receive 10 adjustment points. So just so you're aware, you don't actually need to do anything for that. That one just will automatically be provided. I believe there's no cap anymore. There used to be a cap for adjustment points, so it used to reach a certain number, and then you couldn't receive any more adjustment points after that point. But that's been removed, so now you can receive as many adjustment points as you can. You can also check out other entry schemes and other sort of adjustment point schemes to the right. So there's a QR code, so please feel free to scan that and feel free to read up on it. Now, like I mentioned, we do have something called the Year 12 Engineering and IT Questionnaire, and this questionnaire is actually closing up quite soon. So I highly recommend that if you're considering engineering, definitely submit this, because you can get an additional 3 points out of it, and points like that don't just go walking around for free on the street. Definitely take the opportunity to grab them when you can. Essentially, this is a questionnaire where you'll answer a series of questions. A lot of the questions will be ranging from your motivation to picking your degree, your personal interest in engineering, your affinity for engineering. There is some eligibility criteria. For example, UTS engineering or IT has to be placed as one of your first preferences in UAC. You also need a minimum selection rank of 75. And this is only for those who are a current school leaver, so completing Year 12 this year. But if you are, if you meet all of that eligible criteria, definitely recommend scanning this QR code and just completing it. From memory, it's just a 1 or 2 page questionnaire, and a really good idea for those of you who want to grab extra adjustment points. Now, admissions entry pathways. So of course, sometimes things don't work out, or perhaps you're a bit worried that you might not reach the ATAR that you need to get into your preferred course, and that's completely okay. This happens quite a lot, and it's a very common theme for students coming into university, which is why a lot of universities also have alternate admissions entry pathways. So I've named a few alternate pathways that you can consider just below. but there's different pathways that you can always consider. And this is just a few of them. Very briefly, if you don't get the ATAR that you needed to get into your preferred course, you can always complete a diploma in engineering, and this can be done at UTS College. And then what will happen is that you will most likely end up progressing into your second year at UTS, so continuing into your preferred degree. Generally speaking, most students do continue directly into their second year, so they do not have to repeat whatever subjects they did in the diploma and end up wasting a whole year. So that's quite a smooth transition. If perhaps you don't want to go to the UTS college, you can also do something very similar at a TAFE or a private institution. So generally they offer engineering diplomas, and that's completely fine to do so as well. So essentially you would do your first year doing an engineering diploma, and then you will reapply for your preferred course at UTS. In these cases, you may receive recognition of prior learning, which is really good. So again, that just means you might not have to repeat certain subjects if they are essentially proven to be very similar to UTS subjects. The third option is probably the most common, I find, is where if you don't get into your preferred path, into your preferred course, then you study a very similar course at another university where you know the ATAR is more achievable or something that you know you can get. Or alternatively, you study a very similar course at UTS. And then essentially you will apply to UTS in your second year with your preferred course. Once you've completed that one full year of study, generally it's fairly easy to then transition into UTS. And again, there's always an opportunity for you to receive recognition of prior learning, which is obviously a really good thing. Again, there are quite a lot of other admission pathways, so definitely recommend having a read through that if that's something that you feel like you need to. Or alternatively, definitely pop any questions in the question box and we can definitely answer those for you. Now, for those of you who feel like you might have more questions post the results, once the results get released on the 18th of December, most universities will be having something called an info day. So that's where you can come in and ask any last minute questions. So similar to that, UTS will also be running a info day. So 18th of December, most of it will be web-based. So you can essentially go online, you can watch any last minute webinars and you can submit any questions and get them answered very quickly. You can also call in to ask UTS. So if you just go on Google and type in ask UTS, you'll get a phone number. You can also email them. You can submit a request form and they can get back to you with any answers that you need. In the meantime, we will be looking over to check out some of your questions now. All right, sweet. There's quite a few. All right, so the second question says, I'm interested in the electrical major, but I was curious as to why the renewables major was discontinued.
And I think I'm going to answer that one.
Thanks, Karen.
You might have heard that UTS is going through a process at the moment of sort of reviewing all of our different offerings. There's some decision making going on at the moment where we haven't come to a conclusion yet, but we've been looking at our renewable energy engineering major, and it's perhaps not been as popular as we might have hoped. At the same time, what we're also seeing is the renewables sector is taking off. But as Chris mentioned when in giving his presentation, actually the skills that are needed in the renewable sector itself are those actually that are developed in our degrees. Electrical, mechanical engineers, even civil engineers are really needed in the renewable sector because actually renewable energy and the generation and plugging in of renewable energy into the grid is actually the kinds of activity that power engineers, electrical engineers do as part of their job anyway. What's happened is a shift in those energy sources, not a shift in what's really needed in those foundational skills. So we're reviewing and shifting our focus a little, and we certainly will not be losing that focus on the renewable energy sector. So if you're interested in electrical engineering, you will most certainly encounter learning experiences, projects, connections to industry that are focused on that renewable sector. It's an exciting opportunity, but we need mechanical engineers, as I said, civil, mechatronics, there's automation, there's grid connection, there's all kinds of exciting opportunities. And I think that's one of the best things about engineering. Yes, you choose a major, but even once you've chosen that major, the sectors and industry that needs your skills vary and grow and change repeatedly. So it's an exciting time to be an engineer.
Thank you very much, Karen. I think that answers that question quite well. We also have another one asking, can I do a double degree and the 2 internships? Oh, can I do a double degree including the diploma with the 2 internships and all flexible engineering program? It's probably best for Chris to answer this, but from my understanding, Chris, is it true that you can't do a double degree and do the diploma because the diploma essentially is your second degree?
Not quite, because the reason we have the separate diploma of industry practice is for you to be able to tack on that to your existing double degrees. So this is kind of both questions in the queue. Am I a current student? Can I do a diploma of industry practice? Yes, but we will transfer you into the Bachelor of Engineering diploma of industry practice degree. So we'll actually transfer the degree. But for the double degrees, we intend, because we have to restart the diploma, because we split it up. You have to do three: a Bachelor of Engineering, Bachelor of Business, diploma. Can you imagine the combinations are really painful? What we're doing is we change it so it's a common diploma of industry practice, because the IT students also have the option of doing that 1 year internship. So we've got a generic diploma of industry practice. So yes, you can at this stage. But just a caution, it's not going to be immediately available. We're restarting that diploma for the very purpose of the second question. Do a double degree and do the extra year of the internship as well. So stay tuned. Oh, it's two questions at once. Sorry.
That's actually quite exciting changes being made there.
Yeah.
While we wait for more questions to come trickling in, let's also read through some of the previously answered questions because some people might need a little bit of answers for this. So, yeah, someone was asking whether we offer double degrees. So, for example, Bachelor of Science and a Bachelor of Engineering. So, yep, Chris answered that with yes, definitely. And it's offered via UAC, so 100% if that's something that interests you. Other students are asking whether courses like business also do flexible first year. So, yep, Chris, I'll get you to answer that.
Yeah, basically, Bachelor of Business doesn't have a flexible first year. They actually have the exact opposite. It's a fixed first year. You do exactly the same subjects, the introduction to accounting, finance, human resources, management, leadership, basically the teasers for all their majors. You do that in the first year, and then in second year you go into the major. So you don't choose your major when you do the Bachelor of Business. You choose it in your second year after you complete the first core subject of that major, well, first introduction version of that major. So yeah, it's fixed, but you don't choose your major until second year. Slightly different twist on ours.
No, agreed. I think every faculty does it a little bit different. We have a new question. Which engineering major is in demand in Australia and in industries, which is a tough question, I can imagine. And then the second part to that is, what do you think industries are looking for?
Do you want me to have a go at that, Chris?
Yeah, go for it.
So one of the other things I do, I'm the Associate Dean here at UTS, but I'm also a Fellow of Engineers Australia, which is our professional association. If you graduate from our degree, you're graduated with an accredited degree that's recognised by them. And I'd encourage you to go and have a look at the Engineers Australia website, where you'll find all sorts of reports that they generate about what kinds of careers are available, what sectors and industries are looking for engineers. And it's a hard one to answer. The reason why Chris and I are smiling is because there are so many. There are large infrastructure projects operating all around Australia that need civil engineers, construction, environmental, mechanical engineers, as Chris mentioned, for things like what's called building services, electrical engineers to look at the telecommunications within buildings. There's also lots of projects with advanced manufacturing, telecommunications, defense industries of all kinds of different sorts. Civil engineers who are working in things like smart transport, which is actually how do you kind of model the way transport and traffic flows through cities and design roads, traffic lights, all kinds of other things to make sure people are moving through. There's actually no end of possibilities in jobs. The resources sector, chemical process engineering, for example, I have colleagues who are working at creating sustainable airline fuels, aviation fuels, from the waste products of things like sugarcane and other bioproducts. So how can we take the waste from some chemical processes and undertake another chemical process and turn it into an aircraft fuel so that we can, make less of an impact on the environment when we're getting in a plane and traveling somewhere. There are all kinds of jobs in various mining sectors, and some of those are in areas like critical minerals, for example, which if you've got a mobile phone in your hand right now or watching us on a mobile phone, that is full of critical minerals that make it operate, and we need to kind of be able to have access to those. Again, I have colleagues who are working at how we can recycle and get critical minerals back out again from waste products. So it's really and I'm a bit excited. I love being an engineer, so I could give you lots of examples. But actually, if you do go and look at the Engineers Australia site, one of the things you'll find is their big push at the moment is to try and talk to the government about the fact that we're going to move towards having a really critical shortage of engineers. So engineering is a pathway that can head you towards all kinds of interesting and different careers. And I think if you're worried about how to choose your major, I think listen to Olivia's story and Erin's. Actually, you can come to university and you'll find your fit. That's the reason why we've called this here. You'll get some experiences, you'll get a chance to have a go at doing some things, and you'll find your passion. That's one of the great things also about coming and studying with us at UTS. You get early experiences where you're finding out what it's really like in engineering, and you're better to choose your major on what interests you because all of them have interesting career paths.
I might also add to that, Karen, that engineering is like a generic profession. So the key core skills that you learn as through the core and through the work that you do allow you to move to other disciplines as well. For example, I worked at Enlease. Now that's a civil engineering firm, right? But most of the project managers doing the IT projects were actually civil engineers. Would you believe it? A lot of the electrical engineers I know work in software. It's the engineering mindset, which is a really critical thing that you learn through these degrees. So yes, we don't know what the future is. Maybe in 3 or 4 years' time, there's going to be a quantum engineering type degree. I'm just making that up, but it's probably real actually. So we don't know what's happening in the next 3 or 4 or 10 years. But engineers can move into these because we're both trained through the sciences. We're to train how to think, how to design, how to adapt. So remember, engineer comes from the French word, was a French word, ingenieur, ingenuity, how to design and innovate. And that's a key thing to remember. Yes, you may study civil, but who knows what you will study in 5 or 10 years' time. You might end up being the managing director of a company. Again, a different skill set, but adaptable because of what we train you to do. So yes, a positive field to be in. And I also remember reading a report at, I think it was in Sydney Morning Herald. They had a review of what's the highest graduate pays and the greatest pay after 5 or 10 years. Would you believe it? Engineers were on the top of the list, right up there with doctors. And I thought, whoa, you earn more than a GP in second, third year? Yeah, they earn more money maybe after 10 years of their own practice, but engineers originally at the start earn more than them. So just keep that in mind as well.
I also add something from a student's perspective. I know we've
Sure.
really answered this question. I know it's really like interesting to focus on what kind of majors are in demand, and obviously there are some gives and takes on what there's more of required in Australia. But like it's more about how passionate you are as a student about going out and finding an internship or finding a job. And I can tell you now that like I was not very like keen and trying to get an internship and I kept going, well, there's nothing in mechatronics, like what am I doing? You really just have to go out and look at all the applications available online. And I would highly, highly, highly recommend going to any networking or industry nights because that's going to tell you actually what is out there for your degree and let you kind of know where you can be looking for. Because a lot of the time, especially for mechatronics, I can't speak too much on other degrees. I'll be searching up mechatronics internships and not many come up, but a lot of the time it's like hidden under other things like robotics, automation. I could even apply to some electrical and mechanical degrees. So it really is up to you as a student to go out there. Even if you're a good student and you have good grades, just applying through like your resume and your cover letters isn't enough. You need to be kind of taking your own initiative and making sure that you're making the most of your own degree as well.
I think the clubs are also a good source of internships
100%
as well.
yes.
So if you're doing robotic, are you doing join the Robotic Society? Great networking opportunities there as well. The software societies, great networking opportunities as well. So you'll find that the industry presentations in the clubs for fun or for just interest can lead to opportunities. And sometimes they're a bit different what you expect. I think there's a question in the chat as
I
well.
believe so.
Yeah.
Do you have to pay for bridging courses? I believe so. I think it is around, correct me if I'm wrong, Matt, but I think it goes from 100 to 300. Like it ranges depending on which subject you're doing, and some subjects come in parts. So you might have a mathematics one and then a mathematics two. So if you're obviously getting them in a pack, then it's a bit more costly. It is also, I should note that bridging courses are first come, first serve basis, so they do fill up very quickly. So I would say that if anyone's interested, definitely sort of put it in your calendar, put yourself a reminder so that when the date comes out with all the bridging course dates, definitely get ready to sort of book yourself in because they do tend to sell out quite quickly. I always do get a question while we're still waiting for any last minute questions from our audience. I do get a question quite often about AI and its role in engineering and whether this is going to impact jobs, whether the courses that they do will become redundant if AI is just moving in and updating everything. Any thoughts on that? Or
I'm happy to start, but Chris, you can chime in too. Um, I I don't think that engineering is a profession where generative AI is going to take our place. Because actually, engineering is a profession that requires a lot of creativity and imagination and innovation. And the generative AI tools are useful, handy, and will help you if you come and learn with us to understand where they might be used to support your work. But the developments in generative AI are helping us to do our jobs better, but we still need that human intervention. And in fact, it's engineers and computer scientists and software engineers and professionals in that domain who might be working on creating new generative AI tools. So we're kind of watching and looking at what ways they can help us be more efficient and more effective. And again, Engineers Australia a year or so ago really did a big project to talk to working engineers about how generative AI is helping them. And it was pretty clear it's not going to take over our jobs. It is, however, going to help us to do parts of those jobs more effectively and efficiently. And what that means is that we can activate time for more innovation, more effective working, and draw on the very human skills you need to be a great engineer.
I totally agree with you on that one because, look, a lot of generative AI is not really good at calculations and designing things. They're good at copying things and manipulating it. But what's really useful is their ability to read and understand, or at least summarize huge amounts of data, documents, information that's out there. So you can think of the AI as an adjunct. It's like a buddy. So you think of it's like a gopher. You can ask it questions like, what's the regulation on this particular thing? It'll find the regulation for you. But the key skill that we'd like to teach our students is how to understand whether it's making it up, a hallucination, or is it correct? So the sorts of things we need to do is be able to understand that this information is garbage or not garbage, and then refer back to the original source that says, oh yes, regulation 271/3 of this National Construction Code says this. And doing a Google search for that is so painful, but Copilot can find it for you in 2 seconds, and then you can read it for yourself just to check what it did. The danger of AI with engineering is if a person believes what it says blindly. And that's a skill that we try to make us all. And I've noticed a lot of Gen Alpha, for example, be told, I have daughters who say they don't trust it, even at this group, this level. They don't trust AI. They know that, yes, it says things, but sometimes it's telling you things that are not quite true or distortions of the truth. And so as an engineer, you use your design skills and your innovation skills to work out, is it telling you garbage or not? And that's a really important skill to have. And I think we need to build that for more engineers in the future as well. I look forward to working in that area.
I think that's some good advice for any area of study, I think.
Especially the law profession. They're getting lots of trouble at the moment. Fake legislation. Yoo-hoo.
Well, I think it's good news in what Karen and you, Chris, have just said. So no one needs to stress too much about AI and robots taking over their jobs. There's plenty of jobs out there in Australia, is what I'm hearing from the experts here. And I think with that, we're not getting any more questions, and we have gone a little bit over time, which I apologize for. But when the questions are good, the questions are good. So I think I just want to do a huge thank you to all of our speakers for today. So Chris, Olivia, Erin, and then Karen hopping in at the end, and Matt as well for answering questions. And obviously you as the audience for coming in. Really hope you got something out of this session. And again, I'll be sending it through to everyone so you can sort of have a more in-depth look at everything. Send us any questions afterwards, and wish you all the luck. And hopefully we'll see you guys at UTS. Bye, everyone.
Bye, everyone.